Here we are at example 2C from our 4.3, 4.4 set of notes. And just again, looking at this, we notice just two terms here. We are again seeing that kind of just binomial, and we're asked to factor it. Step one, unfortunately, there is nothing that they have in common that we can go ahead and pull out. So there is no greatest common factor. Then we move on to step two. And that's pretty much where we try to break this up into our two different binomials. Now again, because there's just these two terms, it kind of resembles that whole, a plus b times a minus b. Okay? And if we think carefully, just trying to figure out what is a and what is b, what, for the a value, what squared gives us s squared? Well, s would accomplish that. Okay. Likewise, what squared gives us positive 4? 2 can do that. So in identifying our a and b, we can check and see by plugging them into that difference of 2 squares formula. Now when we do that, we end up with s plus 2 and s minus 2. Because again, we're just pretty much following the difference of 2 perfect squares. Now, when we go ahead and try distributing, though, we end up with s times s. Well, that's s squared. And then we end up with s times negative 2. Well, that's negative 2s. But when we combine the inner two, we end up then with positive 2s. So we're kind of on the right track because these should just cancel out. And then positive 2 times negative 2 gives us negative 4. So unfortunately, we end up with s squared minus 4, but we are really hoping for plus 4. And as a result of this, this is actually the sum of two different perfect squares, and unfortunately, we don't have a way that we can go ahead and just factor that down. So consequently, notice how when we tried difference of two squares, we saw the difference, but we did not see the sum of them. And as a result, this one is actually not factorable. It is not evenly factorable. And that would really be our solution then for, again, example 2C from our 4.3, 4.4 set of notes.